Example 5 and 6 are some application problems. So example 5 says, suppose f of x equals 100 x squared minus 5x, 1,000 units are produced, where x is the number of years after 2000. Okay, so x is the number of years after 2000. My f of x are the number of units produced. So what is f of 10? So that means they are replacing this x with 10. So we are going to replace every x with 10. So f of 10 equals 110 squared minus 5 times 10. And I get 9,950. The answer to part A gives the number of 1,000 units produced for what year? Okay, this is going to be very, very common where they're going to have X represent the number of years after a certain year. In this case, it's the number of years after 2000. So if my X is 10, what year am I in? Well, I'm going to add 10 to whatever year I am after. So this would be 2000 plus 10. We would be in the year of 2010. Let's go to the next page and go over example 6. Example 6 says, if a ball is thrown into the air at 54 feet per second from the top of a 100-foot building, its height can be modeled by the function S equals, where S is in feet and T is in seconds. So you really don't need to know anything about that 64 and 100. They're putting it all into that formula for you. The 64 feet per second is representing my velocity. That 100-foot building represents my starting height. And that negative 16t squared, can you think of what that would represent? What makes things fall from the sky if you throw them off of a building? That right there represents my gravity. So we have my gravity plus my velocity plus my starting height here. Part A, graph this function for t representing 0 to 6 seconds and s representing 0 to 200 feet. So what are they talking about here? That t is in my equation. That's my input. That's my x. So this is representing my x min and my x max. And then s is representing from 0 to 200. S is in place of my y. It's usually y equals or f of x equals. So this is my y min and my y max. So let's graph this function on this window that they are telling us. So going to y equals, and I cleared out my function. And I am typing this in. And I am just putting in x where I see t. That just means my variable. So 100 plus 64x minus 16x squared. Now, if I graph, I'm not going to be in the correct window, so I need to go to window here and change my numbers to the graph it wants me to do. So we're going 0 to 6 for my x. A scale of 1 makes sense. My y max, or my y min and max is 0 to 200. They don't tell you how to do the scale. And to be honest with you, the scale doesn't matter. If I go ahead and hit graph here, I just have a nice straight line right here. Because what that's representing is that each little tick is worth 1. So rather than doing 200 tick little marks, they're just going to do a line, right? If you want some tick marks here, what would be a good representation for a scale? 10 wouldn't be bad. I'd probably go 25. And now I can see all those little increments of it going up by 25 to kind of get a rough estimate. Okay, but this is the projection of my ball. So if I started here off my 100-foot building, so we're 100 feet up, so that's 25, 50, 75, 100. And you throw it, it's going to go up, and then it's going to hit its maximum height, and then it's eventually gravity is going to take control of it, and it's going to come down where it hits the ground. So part A, we have graphed it. Part B, find the height after the ball, find the height of the ball 1 second after it's been thrown and 3 seconds after it's thrown. How can these values be equal? So they should be equal. So because we only need the 2, I'm going to hit trace. So trace 1, enter, gives me 148. I'm hitting trace. After 1 second, the ball is 148 feet, because that's what my S is in. And you can see where that ball is right there. So after 1 second, it's went from the start to right here. I've already hit trace, so I'm just going to hit 3, enter. And I also get 148, which is over here. Okay, now how can these be equal to each other? In the context of this problem, we said it was rising and then it would hit a certain maximum height and then it would start falling because of that pesky gravity. So this first 148 was when the ball was rising. And then the second 148 is when the ball is falling. Okay, now find the maximum height. That maximum height should be your key word here. They call it turning point sometimes, but it's the max. What is this highest point right here? So to do that, again, we're going to hit calc, which we get to by second, trace, and then we will do number 4 for the max. Second, trace, number 4. Left bound, I am to the right. If this is where my max is, I need to go to the left of that. So arrow over. Hit enter. Now I need the right bound, arrow over. My max is somewhere over there, so we're going to keep going. On that guess, are you around that max? And yes, we are, so hit enter again. And my max is 1.9999998. That's basically 2. So we're at 2, 164. Now, find the maximum height of the ball. Which one of these represents our height? My X or my T is in seconds. So after 2 seconds, then my S or my Y represents the height in feet. So my height is 164 feet.